I look right back at 5 years ago when the company looked at building in the future, and we realised that the sustainability of buildings was going to be really important. So from that we looked around what we could control, and what we could control in terms of buildings was what we designed. So I got involved in the design of the building when we decided that, yes, we could see the growth of the Wānaka team really starting to happen, and we needed to get going with that design. John bought this land in 2000, and it was just a paddock. So he's owned it for 25 years. John's vision of what he was going to build here was always quite clear. He wanted to have a timber-based structure that had engineered timber portals, that was predominantly timber walled. Wherever we could have it, the structure was going to be from timber, and also he wanted to have locally sourced cladding on the outside of the building.
Early in the design phase, we really wanted to understand the performance of the building. We ended up selecting 3 different variants: Building Code Plus, our take on green BREEAM, and a passive certified variant. We consulted with Sustainable Engineering Limited, who carried out a thermal model of the building while also taking into account the embodied carbon and performance of those 3 variants. In the end, we opted for the Passive House Institute Low Energy Building certification. This certification is suitable for buildings that don't quite meet the Passive House certification for various reasons, but they are very high performing, very comfortable for the users inside, low energy running costs. It was a really good option for us as a company because it's sort of that next tier down from being a fully certified passive building.
Where it sits in relation to Passive House is Passive House has an extremely low annual heating demand, so the amount of energy you need to heat and cool it is very, very small. With the low energy building, those standards are slightly relaxed, so it's a slightly easier and more achievable target to meet. But there's still very, very low energy in terms of the heating and cooling, very, very airtight, and that's tested, and it still has all of the Passive House features. The modelling, again, is exactly the same as the Passive House standard, and the ventilation system is designed in exactly the same way. BREEAM wanted to achieve a certified building. They wanted to showcase their work to their clients and also to provide the best environment for their staff, which is the primary focus of Passive House. The slab has got 400 millimetres of polystyrene underneath it, so it's an incredibly well insulated building. If we wanted to take it to Passive House standard, we'd just need to upgrade those elements ever so slightly.
When we started considering the likes of SIPs and warm roof construction, those systems actually come with quite a embodied carbon premium. They perform the same as traditional timber construction, and they were more expensive, so we really went full cycle back to just the traditional way of building things. This variant also worked out to be 30% less embodied carbon than that baseline Building Code Plus variant that we looked at, so that was a real big win for us. By encapsulating the slab and the use of timber, it eliminated all thermal bridging. A heat recovery system has been incorporated. We're doing a Stiebel Eltron fully ventilated system. Window design is the likes of triple glazing and PVC windows sealed to the airtight construction. The airtight construction would be a tight thermal envelope where we have an Intello or vapour barrier lining the building. Heat recovery ventilation allows for fresh air to enter the building and be distributed evenly.
I've been involved in this new building since probably its inception, working on planning, figuring out how to do it, who's going to do it, when we're going to do it. Externally, this is one of our key features. Being builders, we typically really love wood, John Breen is a big fan of wood and timber construction. So one of the briefs was to make sure that we utilise wood and celebrate it. Upon entry into our fantastic new building, we'll be met by a reception area, a bit of a waiting room. So a couple of features that we've stuck with on this is the use of wool as a natural product for our insulation. The Terralina bats are right through the structure to create that temperature control.
For all the insulation we have in the walls and the ceiling, we went out to the local farmers of the area and got their crossbred belly wool and sent it up to the manufacturer in Christchurch, who then returned it down to us in the form that we could use to put in the walls and the roof. And quite literally, you can say that the insulation in these walls, keeping this building warm, comes from the paddocks and the surrounding areas, locally grown by the local farmers. We've used locally grown timber for the external cladding. We've got blue laminated portals out of the North Island. We've got recycled materials in here. We have wool carpet.
Last week we had a pretty massive milestone on the site. We had our initial blower door test, so things are trending pretty well to get the final certification. We opted to go for the low energy standard as opposed to a fully certified passive. We saw this one as being the best value for money for what we want to achieve for our team.
The low energy building, in terms of cost benefit, often people in New Zealand will choose to target that because it does mean that it is lower upfront costs and you're still getting a lot of the same benefits in terms of comfort and health, but just with slightly higher running costs. This climate here in Central Otago is one of the most challenging climates in New Zealand. The temperature extremes are much more marked than anywhere else. We have much colder winters. We also have very hot summers, so the overheating can also be a problem. That is one reason why looking at the low energy building standard instead makes more sense down here, because there's just less of a cost premium to go from building code minimum to low energy building rather than all the way up to passive house.
So the performance of the building is really interesting. I've been watching it over the last month around how the solar versus the grid takers and the effect of the sun versus no sun. The building is on average only drawing 5 kilowatts an hour. So over a day, it's only drawing around 50 to 60 kilowatts. And when the sun's out, on a midwinter's day, the solar is creating around 80 to 100 kilowatts. We're putting around about 40 to 50 kilowatts of energy back into the grid every day when the sun's out. Obviously when it's raining it's different. In the weekends when the building's drawing really low, it's putting more back into the grid, but it's very interesting to see how well the building is performing in terms of the load through the day.
There's studies have been done to show that if the temperature is below 15 degrees, your productivity is going to drop off by more than 10%. More than 35 degrees, it's a similar magnitude. So if you're keeping the temperature at around about the optimum of 22, then you're going to increase the productivity of your staff, and that is in terms of fewer sick days, less staff turnover, and better quality work because people are more focused. Aside from the temperature, there is also the indoor air quality. Having low CO2 levels has been shown very consistently to increase productivity and well-being and health.
You come in here and you see all the happy faces and the happy people. You feel the good energy and you feel the even temperature and there's no noise, and the benefits of all that stuff in the building. You go, wow, you know, that's without a doubt the favourite part of it.
I'm hoping this is the showcase for the future, and from it we can generate a bit of change with more people embracing the high performance buildings.
A great takeaway would be that you can build commercial buildings out of timber. You don't need all the steel construction like we've primarily seen over the years.
There's definitely an opportunity for us to be designing more sustainable buildings that will help the environment and more sourced local materials that we could be using and managing the design in terms of minimising the waste. There's a lot of opportunity in that space for us as an industry in New Zealand. This is the first of its type in the country. I think without a doubt, as people experience these buildings, that market will grow. It has to be the way of the future. They're so nice to operate in. They will become cheaper, the knowledge will become more, the designs will get smarter. There is a way forward in terms of more sustainable building for the future.